Hey guys, my name is Jaspeer. Today what we are going to discuss is the first chapter basically on core Java. A little introduction about myself. As I said, my name is Jaspeer. I'm in IT from last 21 plus years now. I started my career as a developer and then I moved basically to QA field. From last couple of years, I noticed that QA field is coming more and more closer to a dev kind of a role. So if you are in QA and if you want to basically grow in your career, if you want to, of course, want to make good money, I think it's must nowadays that you should learn at least one programming language. More and more jobs, they are asking for some kind of automation experience. So if you will have experience with any programming language, it can be either Java, it can be either C Sharp, or it can be either Python. It will be really good for your future, for your career. So in this chapter, in this video basically, the agenda is a little bit of introduction, that why we need to learn actually a programming language, what is actually a programming language is. Then we are going to discuss about compiler and interpreter, and then we are going to discuss what is difference between actually compiler and interpreter. I'm starting these videos actually from very basic fundamentals. You may already know about all these things, but I'm considering that someone gonna look at these videos who may not have any experience with any programming language in past. So just considering that I'm starting from very basic fundamentals. So first of all, most of the time there is a question that why to learn any programming language. As I said, nowadays it's a must that even if you are in QA field, if you really want to grow in your career, you should learn a programming language. Out of 10 jobs, 7 or 8 jobs, they are asking for some kind of experience actually with the automation tool. And if you want to learn any automation tool, programming experience is going to be a really good start. Basically, it will be very easy for you to learn and get familiar with that particular automation tool. Or even if you want to learn actually some automation framework like Selenium, at that time also it will be a huge advantage if you will know Java or C Sharp or Python. Now, question comes, what is actually a programming language? Because this is especially for those who are pretty new to any programming language, actually, who don't have any experience so far. So I will keep it actually at a very high level. Most of the time, whenever we give any instructions to computer, consider that that is basically our high level instructions. So then once we have those high level instructions, we need some kind of interface between us and between a machine, which will convert basically those high level instructions to a machine code. Machine will process those instructions and will send back the result, and then again this interface in between us and machine, it will convert that actually to high level language so that we can understand as a human. And that is basically the process overall, how we write actually a program and how it get transferred actually to low level a machine code, and then it get back basically the results, or according to whatever instructions we give to the machine, it will generate some kind of a result. So in high level, a programming language is actually a set of instructions to a machine, and machine will process it. And programming language, it has we need to follow some specific rules for that. We need to follow some specific syntax, otherwise the machine will be not able to understand if we will not follow rules, if we will not follow some standard syntax. Now, because this is our first video, so I just want to give a couple of best practices that we should follow. And if we will follow these best practices, then it will be very easy for us to basically learn any programming language. So first of all, it's very important that we should understand the fundamentals of any programming language. Don't try to skip fundamentals. If fundamentals are not clear, please ask to your colleagues or to someone who can basically help you if you have any question. Second thing is, any programming language, if you want to learn, it's not like a story that you will read it and you will learn it. You have to do a lot of coding basically at a practical level. You need to type those programs, you need to think about them and then write code and then execute them and then play around with the code. You will learn like that way. Then if there is any issue, if something is not clear to you, always ask for help. Don't just assume things. I think that's very important. Then the biggest thing is sometimes, let us say that I'm working from home and I get stuck somewhere and there is no help around. What you can do is you can go online. There's a lot of information. If you have questions, some specific question on something, if you will put that and if you will search that basically online, you will get a lot of information from there. Then another thing which I learned actually from my experience is that whenever there is an issue, sometimes, especially whenever we are coding, sometimes we look at our code and everything looks all right. And then we are unable to find actually where the problem is. And in my experience, I will say that take a break, for 5 minutes, go out or, just grab a bottle of water or something. And then when you are not actually, in front of your machine, think about that, okay, what you are trying to do and what issue basically you are facing, what kind of, error you are getting, and then come back and at least in my experience, many times it happened that as soon as I came back after that break, I was able to resolve basically that issue or, was able to find that error. Now, let us discuss. We a couple of minutes back, we discussed that there is some interface in between us and a machine, which converts basically high-level language to low-level language. So the first interface is a compiler, as the name suggests. Compiler looks at the whole program at once, convert that actually into an object code, and then that object code, basically the machine will execute that. Now, if we look at interpreter is a little different from a compiler. Compiler, as I said before, it looks at the whole code at once. But interpreter, it looks line by line. So it will read the first line and then will check if there is a error or if there is any issue with that, and then it will move to the second one. So that's the difference between compiler and interpreter at high level, at least at a definition level. Now let us look at what are the differences, couple of more differences. So first one is compiler looks at the whole program at once, interpreter looks line by line. That's why compiler is faster than interpreter. And why it is that, we will discuss that. Now, compiler generates object code. So basically, if I consider Java, we say Java is very portable. What's that mean actually? So you have your program, basically your high-level instructions. Now, your compiler, it compiled that code, it created actually an object code, which is pretty much independent of the machine where you compile that code, or the operating system or the software you are running actually on that particular machine. This object code is independent of that. So you can carry this object code on a Mac machine or on a Windows machine or a Unix machine, anywhere basically, and you will be able to execute basically that object code. Interpreter is not like that way. Interpreter actually depend actually on your hardware, on the operating system, where actually it is executing that program. Now, in case of compiler, the conditional statements, and we will learn about them, conditional statements and logical expressions. In case of compiler, the execution is faster when we compare with interpreter. Just for right now, just remember that. compiler takes more memory in comparison to interpreter. The reason is compiler is generating this object code. Interpreter is not generating that object code. It is not keeping that. It is just directly interacting actually with the machine. So that is the reason compiler is taking more memory in comparison to interpreter. Then once one program is compiled, you don't have to recompile it again and again. Especially like, as I said, Java is very portable. So you compile your program, you have object code, and compiler says that everything is all right. Now you can simply carry that object code to any machine and you can execute that, you can run it. But in case of interpreter, every time, whenever you will try to run it, it's going to compile it again. So it will go read first line, then second line, and third line, and fourth line. But compiler, once you compile it, you can simply execute it. Now, it's very easy to debug basically any program in case of interpreter, because as soon as it will find any error, it will stop over there right away. But it's hard to debug the program which is actually going to be executed or getting executed actually by compiler. The reason is because compiler is looking at, let us say, 50 lines or 100 lines all together, and it's very hard. Basically, we have to start from the top and find out that, okay, where the issue is actually. So that's basically the couple of differences between compiler and interpreter. Now, Java, basically, as I said, Java it is using actually a compiler, but now a little bit internals of it. So whenever Java compile any program, it generates actually a class file. Now there is a JVM, Java Virtual Machine. Now this JVM is hardware specific or operating system specific. So we carry this object code, and if I want to execute that actually on a Windows machine, I will give that object code to Windows JVM. So this Java Virtual Machine, it is basically on RAM. So what it will do is, it will inside a JVM, there's a class loader. So just for right now, I think just understand that there is one component class loader, and this is a class file. So it will just load that class file, that object code, and it will execute that one. Now this JVM internally, once it load that object file, it's going to execute basically that object code as an interpreter. So that's very interesting actually. So itself from Java, like whenever there was a source code, and when you converted that object code, it was a compiler. But inside JVM, now this object code is going to get executed as an interpreter. So JVM itself inside is basically executing that code as an interpreter. Next chapter, what we are going to discuss is what is Java, when and who invented it, features of Java, and what is actually object-oriented concept is. Thank you very much.